Okay, so in this video we're going to take a quick look at transforming data. So as we do different transformations, what will they do to our summary statistics? So that also might be something, make sure we're aware of what the summary statistics are. So um, if we look at, here's some data on the heights of 7 different people: 76 inches, 71 inches, 68, 65, 69, 70, and 70. So if we put this data into, for example, into your calculator in list 1, you're going to find the summary statistics. If you look right here, the summary statistics, that's what I mentioned before. That's what you're finding when you use the one var stats, all that different stuff that it tells you about the data. So let's say we go ahead and do that very quickly. For this particular set of data, we come up with this information, right? X bar, the median, standard deviation, and then by subtracting max from min, we get this particular information, right? So if we said, well, maybe instead of inches, we'd like to go over here to feet. Maybe we'd like to convert to feet for some reason for our, for our purposes. So what we have to do is we have to divide everything through by 12, right? 12 inches in a feet, in a foot, excuse me. And so then we want to now go ahead and find the summary statistics and fill in the table. So one option, we could go into L2, and then up at the top we could take L1 divided by 12, and then rerun our one var stats. The other option, and then kick back these numbers, excuse me. If you'll notice, however, all of these numbers, as we go from inches to feet, all of those are just the original divided by 12. So there's something happening here. All right? So one option, convert all of our measures and then, right, convert all the original data and then create the summary statistics. Or what we can see here, we could have just divided by 12 from our summary statistics to get our new set of summary statistics. So when there's multiplication and division, we could just multiply or divide our summary statistics. Also really helpful. Maybe maybe you don't have the original data, but all you have is the summary statistics given to you in some kind of list or table. Maybe this is all they give you, right? We didn't know that there was a 70-inch person, a 70-inch person, a 65-inch person, a 68-inch person. They just said, hey, here's some summary statistics about a group of people in inches, but we want them as feet. Well, good news, we don't have to have the originals. We can just divide through by 12. So let's fill in the rest of this table. So let's say that we've got the weight of 8 different people. So again, we can put this data into a list, finding the summary statistics. You do 160, 98, 103, 115, 125, 140, 118, 155. You put that in, you do your one var stats, right? That's how you're going to find your summary statistics right now in the class. And that's going to be a lot quicker than doing everything by hand, right? Ordering everything, counting to the middle for the median, adding them all up, dividing by 8 for standard deviation, or for average. The standard deviation process, which we saw a few days ago, was very time consuming, but the calculator does it for us very quickly. So if we do that, we should end up with these values right here: an average weight of 126.75, a median weight of 121.5. We got a standard deviation of 22.95 pounds, and then a range of 62 pounds. So let's say all of a sudden, though, somebody that recorded the data found out the scale was overweighing people, so their scale was off. So instead of having to go back at the beginning and reweigh every person, or go back and convert all of these, subtract 3 from each and every piece of data, which here, not too bad because there's only 8 of them, instead of having to do all that, what we might be able to do is do a transformation. We need to subtract 3 from all the weights. And so if we look here, for some reason my 123.75 decided to take up 2 lines. If we did it in the calculator, right, if we did in L2, if we did L1 minus 3, right, let's say that we put our weights, right, in list 1 before to find the summary statistics, and in list 2 we just subtracted 3 and did the one var stats again. What we should notice all of a sudden is there's something a little bit different happening. Right? Initial reaction might be, hey, we're subtracting 3, so kind of like when we divided by 12 over here with the heights. Maybe when we subtract 3, we just subtract 3 from everything. But all of a sudden, these two things, the standard deviation and the range, they didn't change. And upon, further reflection, if you think about that for a minute, if everything shifts 3, the data doesn't get more spread out. Obviously the center, right? The center, which are these two things, obviously that's going to shift down 3. However, if you think about the range for just a minute, if both the maximum and the minimum slid down 3, the range isn't going to change. If everything's sliding down 3 values, the overall spread isn't going to change at all when everything shifts the same amount. So, another way to kind of think about this, here we go. Here's a table if we go distance in meters to kilometers. So here's one of these things. A lot of times this multiplication division is going to show up when you're doing some kind of conversion. So here's an example. We don't have the actual data, but somebody's collected data, run the summary statistics, and this is the information they've come up with, right? But then all of a sudden another researcher comes back and says, I'd rather not do it in meters. I'd like to report something in kilometers. So it's pretty straightforward, right? We're going to divide by 1,000. And since this is a division situation, that means everything can be divided, right? Test scores, some pretty obvious, or some that we probably are all familiar with, but also let's say we want to do a 10-point curve. Well, that's like adding 10 points to the curve. Well, the mean and the median then are obviously going to shift up, but the data is not getting more spread out. So again, here we are, measures of spread not changing. So you kind of put it all in one big place. When you multiply or divide a set of data by a constant, you're going to multiply or divide this center. You're going to multiply and divide the measure of spread. Right? And that's because everything's being multiplied or divided. That's another way to think about it, is that when you multiply or divide a set of data, everything gets it. However, when you add or subtract, you will do that to the measure of center, but the measure of spread, there'll be no effect.